Okay, we are going to answer a question. Hey, you know what? Since we answered questions the other day on this is the last question I'm answering. Okay? No, oh, did I just give you this yesterday? That's right. Okay, I'll answer a couple. Okay, here we go. What's A, B, and C? And positive 8. I like to identify them. You guys, I know you guys, once you get good enough, you can just pick them out of the problem, but I notice a lot of times when you do that, you forget things like negatives. So just in case. All right, so we have x equals negative b. What would the negative b be? 8. Plus or minus the square root of b squared minus 4ac. But we already figured that out because we did the discriminants the day before, so 192. All over 2 times a. Negative 8, because 2 times negative 4 is negative 8. Okay, once we get this far, we have to be able to simplify. And to simplify, we're going to start with breaking down 192 to see if we have any perfect squares in it. And so 192, we know 192 is even, so we know 2 goes into it. 2 and 96 will work, or 12 and 16 will probably work. Okay. 4 and 24. 2 and 2. Okay, 2 and 12. 6 and 4. No. 2 times 6. 2 and 3, right? We have a pair of 2's. We have another pair of 2's. And we have another pair of 2's. And we have a loner 3. So we've got 3 pairs of 2's. 2 times 2 times 2, because we take 1, 2 from each pair, times the square root of 3, right? Well, 2 times 2 times 2 is 8, so 8 square root of 3. So we're going to go back up here, and we're going to write this as 8 plus or minus 8 square root of 3 all over negative 8. What? We can. Because now we look to see what number goes into these 3 numbers right here. 8, 8, and negative 8. Well, we know that 8 goes into all of them, right? In fact, let's divide negative 8 into all of them. So 8 divided by negative 8 is negative 1. And since this is plus or minus 8, now it's going to be minus and plus 8, which is the same thing, right? So, and divide 8 into that, that's 1. So we have 1 times the square root of 3, all divided by 1. But technically we don't need that, so the 1 on the bottom. So our answer is x equals negative 1 plus or minus the square root of 3. Because we decided since there was a negative 8 on the bottom, we're going to divide by a negative 8. So that we have a positive 1 on the bottom. So that changed the sign up here. Yes. I didn't do which one yesterday? Thank you. Oh, only on one where you couldn't go any further. Did you watch the video and did I do that? Thank you for watching the video, Austin. Did you watch the video? Good job. Yeah. If there's any dislikes on there, I know where they come. I really don't check to see if you guys like or dislike, but I don't even know how to do it. I don't even know where to look check. Carly Garrett and Kyson Spinlove. You guys are supposed to go to the counseling office right now. Okay? Hey, we are, you guys will probably have to watch the video or come back and get your friends. Okay. All right. Any other questions? I'll go over, yes. 25, Kayla. Okay, negative 2x squared plus 9x plus 1 equals 0. Okay, we got to figure out A, B, and C. What are A, B, and C? What's A? What's B? And what's C? Okay, we're going to use the formula. I didn't write the formula out last time, so I'm going to write it out this time. Okay, so we got someone at home watching this and needs it. Okay, so we make substitutions. Kai, what am I going to substitute right here? Okay, what would I substitute right here? 81. Does everybody agree that that discriminant's 81? 89. Okay. Okay, 9 times 9 is 81, but we that was due the day before. That was the discriminant assignment. Okay. What goes right here, Kai? Negative 4. Okay, now, if you look at this, you guys, is 89 break down? In fact, I think 89 is a prime number, isn't it? Okay. So guess what? That's our answer, because it doesn't simplify. Okay? Any other? I'll do one more. 127? Do you guys want to do 27 or not? Yes. X squared. Okay. All right, though. You guys got to quit yipping. Alex, if I'm going to do this, you guys got to listen. Got it? I can't talk above all of you. If you guys know this well enough, we can just go on. Otherwise, you got to listen. Okay, what's A, B, and C? 1, 9, and negative 9. Okay, so x equals negative b. What would that be? Plus or minus the square root of the discriminant, which 117. Does everybody agree with that? Over 2 times a, which would be? Ooh, you know what? I can see one number goes into 117. What is it? 3, because 1 plus 1 plus 7 is 9, and we know that 3 goes into 9 using our little trick, right? So 3 times 39. Oh, guess what? 3 plus 9 is 12, and 3 goes into 12. So we know 3 goes into that. 13 times. And 13 is a prime number, so are 3's. So we have, what's our answer? 3 square root of 13. We got a pair of 3's and a loner. So we have 9 plus or minus 3 square root of 13. Negative 9, sorry. All over 2. Now, is there a number that goes into 9, 3, and 2? No. So we're simplified. Okay. That's it. Okay, you guys, today we are going to kind of the ending of making sure we know how to do quadratics. We're going to be solving quadratics that have complex functions. This number 4 of these objectives that I've had up here for a couple of days. Okay, and so what do I mean by solving quadratic equations with complex solutions? Everybody, get out your foldable that we just did. Oh, I meant to turn it back to you. Okay, let me just talk about it, and I'll get it back to you today. Remember, that we looked at some quadratic equations. We looked at some where they never crossed the x-axis, somewhere it crossed it twice, and somewhere it crossed it once, or it just touched it right here at one time, right? And we found out that the ones that touched it one time had one real number solution, right? In other words, its solution was a real number. We found out that those that crossed it twice had two real number solutions. But we found out that if it doesn't cross the x-axis at all, it has what? Two imaginary number solutions, right? Technically, all three of these are complex roots. But when they usually say complex solutions or roots, they're talking about that it's imaginary, because we usually write them in the form a plus bi, where we have an imaginary part, okay? So this is the kind of problem we're going to be doing today, because not all parabolas cross the x-axis. Do we understand that? Not all parabolas are going to cross the x-axis, but they do still have solutions. We say that they are imaginary solutions, which they're not really imaginary solutions, they're actual solutions. I'm figuring that some mathematician a long time ago decided to call it that because you couldn't physically see it on a graph. But they are actual solutions, okay? And just a reminder, I equals what? Good, square root of -1. Do you remember that from earlier in the year? Okay, sounds like a lot of you do. I equals the square root of -1. So if I get something like this, the square root of -16, that's equal to, not 69, 4i. Why 4i? That's not -4i. Square root of 16, because you can break this down into the square root of -1 times the square root of 16, right? And what is the square root of -1? I. And what is the square root of 16? 4, and so you get 4i. Okay? All right. Let's look at another one. Let's say I had the square root of a -24. Okay? If I had the square root of -24, I could break that down. Well, first of all, 24 breaks down into what? 6 and 4. I can simplify that one. 2 and 3, and 2 and 2, right? I have a pair of 2's, a loner 3, a loner 2. So what does that make? 2 square root 6. But because it's negative, you're going to have to put an I. So we put it 2i square root 6 like that. Because otherwise, if we put it after 6, it would look like it's under the square root. That's why we don't normally do that. You can write square root of 6 times I, and some people square root of 6i, but some people misinterpret that as the I being inside the square root, which it's not, because the I equals the square root of -1. Okay? You can have an I inside the square root if you had the square root of -1. Okay? But in this case, we don't have that. Okay, kind of get the idea right there? Now, what we're going to be doing, today's assignment, the only difference is every solution actually is going to be the square root of a negative number. So you're going to always have an I. You're going to have the imaginary number I in every solution today. So we're going to do a couple. On that worksheet I just gave you, we are going to start and we're going to do number 4. So everybody go number 4. 6x squared, well, 4 isn't even, so. 6x squared plus 9x plus 10 equals 0. All right, so we're going to be solving this using the quadratic formula. We need to know what a, b, and c are. And we are going to use the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a, right? Okay, what is a? 6. What is b? And what is c? 10. Okay, so We're going to make the substitutions here. And you know what? I always like to find b squared minus 4ac first. Let's find our discriminant. Okay, what would b squared be? 81, because b is 9, 9 squared is 81. Minus 4 times 6 times 10. If you guys want to use your calculator and just type that out. Okay, we get negative 159. So, anybody verify that? Okay. Camera said it, it must be true. X equals, okay, now let's make the substitutions in the quadratic form. X equals negative b. What would that be? Negative 9 plus or minus the square root of negative 159, all divided by 2 times 6 is 12. Okay. I can see one number for sure goes into 159. What do you think? 3, because 1 plus 5 plus 9 is 15, and I know 3 goes into 15, right? So 159 breaks down into 3 times 53. We don't need to worry about the negative because we already know that that's just going to be an I, square root of negative 1. Okay, how about 53? I think that's a prime number, right? Therefore, is this simplifiable? There's no pairs, so that's our answer. Oh, wait, we got to rewrite it without a negative inside square root. So what is that going to be? I times the square root of 159. So negative 9 plus or minus I square root of 159 over 12. Any questions there? Let's do one more. Yeah, that's all you're doing. Okay. Hey, let's do number 10. Everybody go to number 10. 4x squared plus 3x plus 9 equals 0. Say that again. Well, okay, let's go back. 159 is inside the square root, so we can't take, we can't, you know, even though 3 goes into all of those, we can't do that. It has to be number outside the square root. The number inside doesn't count, okay? All right. Okay, right here. What is A? What's B? And what's C? 4, 3, and 9. Okay, B squared minus 4AC. 3 squared is 9 minus 4 times 4 times 9. 9 minus 72 is negative 63. Is that right? Is that what the answer? You got negative 135? 4 times 4 is 16. I did that in my head, and what'd you get again? Negative 135. Okay, so x equals negative b. What would that be? Negative 3 plus or minus the square root of negative 135 all over 2 times 4 is 8. Okay, 135. 3 goes into that, doesn't it? 1 plus 3 plus 5 is 9. 3 goes into 9. So we know that 135 breaks down to 3 times 45. And 45 breaks down to Okay, 9 and 5, and 9 breaks down to 3 and 3. Got a pair of 3s, a loner 5, a loner 3. What's that going to make? 3 square root of 15. So we have negative 3 plus or minus 3 square root of 15. Oh, I forgot something. What did I forget? Where does it go? After the 3. 3i square root of 15. Yeah. That's about as hard as it gets. Okay, you guys, your assignments, the odds. Yes, we did. Okay, do the odds. Do the odds on here.